Hello, everyone, and thank you for joining. Today's webinar will talk about 3 steps to reduce security risks in your software. My name is Rami. I am the CEO and co-founder of WhiteSource, and I'll be presenting today's session. And without further ado, let's get started. Our agenda today was first to discuss security vulnerabilities in general, try to explain a little bit what we mean when we say security vulnerabilities. We will then discuss 3 required steps basically to reduce security risks in the software that you develop. We will then answer some of the questions that you guys have sent us prior to this webinar. We've had a lot and we won't be able to cover everyone. And then show a demo of the WhiteSource system, which pretty much automates the 3 steps that we'll cover. If you have any additional questions that you come up with during this session, please type them in the control bar. We will collect all of them, combine them with the previously asked questions, and distribute the answers by email. Since pretty much all the questions we got were very good, we decided that we will send a t-shirt out to anyone who has posted a question for this webinar. So with that, let's get started. Security vulnerabilities, namely security vulnerabilities in open source components, have become somewhat of a big issue over the last year, primarily since the emergence of Heartbleed and Shellshock that made headlines worldwide and were very heavily discussed and analyzed and researched and so on. Unfortunately, Shellshock and Heartbleed are just the tip of a much larger iceberg of vulnerabilities that are known to exist in open source components, but they are not known to the general public. They are discovered and curated by security repositories and specialists, and they are certainly well known by hackers and other exploiters, but the general public and the public of people consuming open source components don't have a good way of knowing about all the vulnerabilities that are being discovered, certainly not in real time or in relevant time. And naturally, this can affect anyone who's developing software, and to a large extent. We've conducted our own little research on data from our real commercial customers. We've analyzed over 6,000 projects and found that about a third of them had vulnerable libraries embedded in them. An average software product has a little over 10 projects, which statistically means that there is a very high probability that in your software product there are at least a few vulnerable open source libraries, and basically that makes your software vulnerable. So what are the 3 steps that help reduce security risks in your software? 1 is to know to the full extent which open source components are being used. 2 is to handle vulnerabilities in those components. And 3 is to continuously track, monitor, and mitigate new threats as they come in. Step 1, know the open source components that you are using and that your developers are adding to your software projects. So what is your software comprised of? It's comprised of 3 types of software parts, let's call them. 1 is the software being developed by your own developers. This is original proprietary software that is normally very well managed and scrutinized for bugs and security issues. 2 is the third-party components, commercial third-party components that have a mother and father, and someone that takes care of their bugs and their security vulnerabilities and so on, and tries to keep up with them and alert you when there are severe issues that need to be taken care of. And there aren't that many normally. On average, you'll see very few commercial components in a software project. A very large part of your project is actually comprised of open source components, and this part keeps getting larger and larger every year. It's in the range of between 50 and 80% of an average software project commercially distributed today, and that just keeps growing all the time. So first things first, you need to know which open source components your developers brought in, embedded into your software, and are now an integral part of whatever you guys are developing and distributing. Keep in mind that software, that open source is software in its own right and can depend on other bits of open source, which can depend on more open source components and so on. So even if you directly track the components that developers bring in, it's virtually impossible to track all of the transitive dependencies that eventually are embedded with your distribution. And we need to keep in mind that selection of open source or introduction of open source components into your software has far-reaching consequences on architecture, on performance, on security, and the quality of the software product that you build. And these, even without having vulnerabilities in them, can make your software more or less exposed, more or less secure. The type of architecture you choose has far-reaching consequences on how well your software can handle malicious attacks and how it can adapt to changes in the field of security and known attacks. Second is understanding the existing vulnerabilities in the components that are already being used. And how is that done? First, you'll get a report of vulnerable libraries that are already embedded in your software. You'll need to review that report and then prioritize how you want to handle, in what order, and what sort of mitigation steps you want to take. And then take those mitigation steps by either upgrading to newer versions, replacing problematic libraries with others, or doing some workaround as recommended by the community or by your own developers because they found some solution that doesn't require replacing a library that they want to keep working with. Again, from our research, we know that almost all commercial software products have vulnerabilities that derive from poorly maintained open source components. And there is sort of a disconnect between all the good work, genuinely good work done by open source communities out there, which tend to be very alert, very attentive, and track, monitor, and identify security issues very quickly, and then release new versions and patches to fix those vulnerabilities, and generally do a good job. But they are disconnected from their end users who have a long duration before finding out about said issues or the fixes, if at all. So for the most part, people who use the open source components are remote from the communities that generate them and don't know about the security issues or the fixes that those communities push out to the market. This is sort of a good news, bad news situation. The good news being that there's normally a very easy fix to security, to a known security vulnerability in an open source component. You just need to upgrade to a newer version. And our research backs this up, and we found that 95% of the vulnerable libraries have newer version, but has just not been updated by the developers. And finally, you need to make sure that going forward, you will stay secure and you'll keep monitoring for new potential threats. And the way to do that is, one, monitor for new vulnerabilities that are found in the components that are already embedded in your software. And two, check the new components as they come in and see if they have any known vulnerabilities. The most popular repository for known security vulnerabilities is CVE, and that they again do a very good job of curating security information and publicizing it, and we thank them for that. As a practice, you should implement open source monitoring tools or attention throughout the software development lifecycle. So in the development stage, you'll need to check components, open source components, for potential issues. This can be security, version information, or licensing issues while you're adding them to the project. When building is a good time to do a cross-cut check of all the components that go in the build and match them against your policy and make sure that your policy is held in that build. Testing is a good time to review any special cases if some library needs special attention or you need legal intervention or security specialists to come in. And when you distribute, you should be able to produce compliance reports and be able to demonstrate that indeed your software is robust, secure, and compliant with requirements by customers, partners, or anyone else that wants to know that the software is doing well. All right, at this point, we'll try to answer at least part of the questions we got from the audience. First one being, how is it possible to stay informed about changes, updates, bugs, corrections, or new versions of all the different components? The answer, as alluded to previously in the presentation, it's very difficult. It's almost impossible to do manually, specifically because of the transitive dependencies that come with your direct dependencies. There are many hundreds of components in an average project, but white source can do that automatically for you, and I'll show you that in the demo very soon. Next question is, how can we bridge the gap where different open source may be called different names? This occurs even in NVD or other official sources for security vulnerabilities. That's correct. That's actually a non-trivial problem that we've decided to take on. We've spent some time and resources developing an automated system to match vulnerabilities with specific open source components in specific versions. We use pattern recognition and some hints and clues hidden in the vulnerability description, as well as in metadata that we have in our database about the open source components, so not just by name. And we have a system. So the answer is that it's not easy, but there are automated ways to do it for you. Another question, what is the difference between security code scanners and your offering? So generally speaking, there are a few very good vendors who provide security code scanning, and what they do is they try to find potentially problematic patterns in your code, or you can try and run them on open source code and get much more results, but all of those are heuristic results, and you tend to get a lot of them, and you have to review and see if they are even relevant to you and so on. The type of information that we provide is real, actual, known vulnerabilities that have been exploited in the past or have a very large potential of being exploited because someone actually proved that they exist in an open source component. So when we tell you there is an open source vulnerability in a component, then it's certainly there and requires attention. To sum up, vulnerabilities are difficult to keep track of. There isn't much awareness, and developers have a hard time tracking the hundreds of different components back to their origin, to their community, try to understand when and if a vulnerability was found and what the fix is. The information distributed about them is not easy to understand, and there is no real way to see all of your issues in one place and to prioritize them or make sense of them cumulatively. We found that very rarely do software developers even proactively look for vulnerabilities because the manual task is so overwhelming, and therefore you are most likely unaware of vulnerable components that exist in your software and will not know when a fix is being released or when a new version is released that can mitigate your issue. And so it's very likely that your product will remain exposed for a very long duration before taking care of the exposure. So now that we have a better understanding of what the problem is and what the 3 steps that should be taken are, we at WhiteSource can basically help you do all of that automatically without any hassle and without any manual investment. WhiteSource offers a very lightweight, easy to use cloud-based service that has an extensive and continuously updated knowledge base about open source projects, including licenses, vulnerabilities, versions, and so on. It's connected directly to normally a build tool in your environment, and then continuously monitors open source coming in, and basically enforces your policy for you, generates reports for you, alerts you when you have potential issues that you need to deal with, but lets you keep on doing development and going about your daily business when possible and not waste your time on issues that are not core business for your company. The way that we work is that we integrate with a build tool and then take all the information from a given build about the components that are being used and match them against our database of known components, and then look for known vulnerabilities on those components so we can let you know about them immediately. We then keep monitoring your inventory, and if we find new vulnerabilities being publicized about any of your components, we will also alert you to them, and we'll also monitor new components being added by your developers and let you know if they are vulnerable. So we basically take care of all of the 3 steps that we talked about for you in a completely automated manner. And with that, I'd like to show you a demo of what our system actually looks like. And being a cloud-based software as a service solution, the solution is accessible from your browser. You don't need to install anything other than the plugin to the build tool. And you immediately get a set of dashboards and reports that shows different aspects of your open source inventory. The page that we're looking at right now is the home page of the service, or the organizational dashboard, that's generally divided into 3 parts. The top part is the alerts, which I'll get back to in a second. The middle part is a mini inventory broken down into products. So for each of your products, you'll be able to see the list of components with their license and a breakdown of risk factors for those licenses. And at the bottom, you see tickets of new libraries coming in. And normally, new libraries coming in would be handled by an automated policy, which I will also show you. But in the rare case that the policy did not apply to a specific library, it will start a workflow and send an email and require someone to manually make a decision about what to do with that library. You can also drill into any given library and get a lot more information about it, including its dependencies, identification information, known versions, older or newer than the one that you're using, a link to the homepage where the code is stored, and so on. And you can drill down to the license and try to make sense of what the license means for some legal potential issues, if that's what you're interested in. But let's go back to the alerts and tell you that once the system knows what the inventory is made up of, it can start generating some insight into that inventory. And you can see we have all these different types of alerts here: policy rejection alert, new version alert, and the security vulnerability alert. And specifically for security vulnerabilities, we have a designated report that lets you see all of the vulnerable libraries in one place, so you can prioritize the vulnerabilities that you want to handle first. And you can, of course, drill into any specific vulnerability and get a full disclosure for that vulnerability, the listing information, the disclosure date, severity information, the impact on your system. So this vulnerability may impact a few libraries that go over several of your development projects. They will all be listed here, and references to potential fixes, upgrades, or workarounds that can help you mitigate said vulnerability. If you like, you can go all the way and open the CVE page for that vulnerability. It might give you some additional information if you need it. You know, for, I don't know, auditing or reporting reasons. Sorry. Of course, there are additional reports. There is the flat inventory report that lists all of the components with a short description for each, the license, and occurrences in various projects. And with the click of a button, this report can be exported to an Excel spreadsheet that can then be shared with an auditor, a customer, a partner, or whoever you need to share this with. And the nice thing here is that it takes maybe 10 or 15 minutes to set up this operation. You install a plugin to your favorite build tool, you run the initial bootstrap data loading, and you are good to go. You can immediately produce reports, look at the vulnerabilities, start mitigating them, and so on. It is also advised that you set policies, how to handle new libraries coming in. There are a few types of policies in our example here. We have a blacklist of licenses that excludes GPL from entering our project, so we would automatically reject any GPL licensed library that the developer is trying to add. On the other hand, there are a few licenses that we are okay with, such as BSD, Apache, MIT, and others. So these will be marked to be automatically approved when they come in. We can also have security-based policies where we can set different severity level as our tolerance level for specific products. So if we have a mobile product or a web-based product or a back-end product, we can set different tolerance level for security vulnerabilities for those products. And the way that the policy operates is actually one of two ways that you can choose. Either you can fail the build, so you can set the plugin to fail the build on policy rejection and thus cause a developer to stop in his tracks if he's trying to add a highly vulnerable library to a sensitive project. Alternatively, if you don't want to break the build, you can configure it so it will open an alert and then send an email and then have someone responsible take over and do the mitigation process after reviewing all the relevant information in our system. And with that, I think we cover the basic functionality of our system. So let's go back and summarize. So we all know open source is great, but some of the benefit can be diluted by security or quality issues, licensing or compliance risks, and the laborious, resource-intense manual management process of having developers report on each new library that they're adding, and then maybe manually research its dependencies, try to figure out if they are vulnerable or not. There is certainly no manual process for doing reviews on past added libraries. So if some developer added the library 2 years ago, the developer may have left the company by now. I've never seen anyone that goes out and then actively looks for new vulnerabilities for the components that were added. So it's very difficult and I would say almost impossible to achieve a good process manually. And then white source comes in and provides a very lightweight, very easy to use a solution that fits seamlessly into your existing development environment without any interruption, proactively alerts you on vulnerabilities and fixes as they are found or as developers are adding potentially problematic libraries to your projects, automatically enforces your declared policies, so you don't have to do almost anything manually, and basically takes the R&D team out of the loop. So you can define your policy and your connection and reporting requirements, and then set the system to run automatically and free up your development resources to do the important work that they have to otherwise do. It's a very fast, very easy, and cost-effective solution to take care of your existing and future open source in your product. And with that, I'd like to thank everyone who attended, and I'd hope to see you in person sometime soon. So everyone have a good day, and thank you again for joining us today.